In our lesson today, we're going to be doing 29.3, graphing rational functions. So we started this a little in class today, but we're just going to be identifying more key parts, which are the x-intercepts, y-intercepts, and horizontal asymptotes. Okay, so make sure you have the note sheet that goes along with today's video, something to write with, and a calculator or Desmos to help you with maybe some graphing. Okay, so let's start by talking about the horizontal asymptote. So a horizontal line is a line that runs left to right. Okay, so in class today we did vertical asymptotes. Those go up and down. But a horizontal asymptote would look like a line that goes from left to right. Okay, remember an asymptote is a line the function will approach but never actually cross. So it could look something like this. Okay, where the line would approach it but not actually cross it. Okay, so horizontal asymptotes depends on the degree. Remember, the degree is the largest exponent of the numerator and the denominator. So basically, we just look at how the numerator and the denominator compare based on their highest exponent. Okay, and there's three types of scenarios that we can have. Okay, if the degree or the exponent of the numerator is just as big as the denominator, so our degrees are equal. So for example, if we had something like x squared over x squared. So the biggest exponent you had was the same number. Okay, that means your horizontal asymptote is going to be the ratio of your coefficients. So say I had a coefficient here of 4 and a coefficient on this one of 2. Okay, 4 over 2, your ratio, so you would just divide that out. Okay, so that's your first scenario. The second scenario would be if you have the numerator is smaller than your denominator. So for example, if your numerator was x and your denominator was x squared. Okay. When that happens, your horizontal asymptote is always at 0. Okay. And then our last scenario is if our numerator has a bigger degree than our denominator. So again, another example, if I make this x cubed over x squared. Okay, so if the numerator has a bigger exponent, then you have no horizontal asymptote. Okay, so those are your three types of scenarios. Either your degrees are the same, then we look at their coefficients. If the bottom is bigger, it's 0. If the top is bigger, you have no asymptote. So let's look at these examples that we have here. Looking at our biggest degree, our biggest exponent, we would have to look at our variables here. So here we have negative x over x. Okay, well, these both have the same exponent, technically a little imaginary degree of 1. So 1 is, since it's the same on top and bottom, we would take our ratio of our coefficients. So our coefficient on top is a negative 1. Our coefficient on the bottom is just a little imaginary positive 1. So that makes our horizontal asymptote then at negative 1. Okay, and it's a y equals line because it's a horizontal left to right line. Okay, let's look at example B. If I look at my x's, okay, we have an x squared on top with an x on the bottom. So this is scenario number 3 where your numerator is larger than your denominator. So that means we have no horizontal asymptote. Okay, maybe I'll put none instead. Okay, so why don't you guys try C? This one you have an x on top and an x squared on bottom. So you have a smaller degree on top and larger degree on the bottom. So when your denominator is bigger, where is your asymptote? Anytime your denominator is a bigger exponent, your asymptote will be at 0. Okay, those are your three rules. Either they're the same, then you look at their ratio of coefficients. The bottom's bigger, none. The top is bigger, 0. Okay. Now the next part we did in class already together, but that's those vertical asymptotes in the holes. Okay, so rational functions have discontinuities or breaks in the graph. There are two types of discontinuities: vertical asymptotes, which again would be a vertical line. If I draw one in here, like this, and it'd be a line that the function could approach but never actually cross or touch, like that maybe. Okay, and the other one would be a hole. So if we had a break in our graph, like that, and it kind of skipped through that line. So maybe I'll redraw that. Okay, a hole would look like this. Okay, those are discontinuities. They break the graph up. That's not continuous there. Okay, so the way we get that is by factoring. Okay, we factor the numerator, factor the denominator. Anything that gets crossed out would be considered giving us a hole, and anything left in the denominator would be a vertical asymptote. So I'm just going to go through A. On the top, I can factor an x out from each term. That's going to leave me with x minus 1 left over. Okay. On the bottom, I have a trinomial. So we have factors of -4 that add to 3. So that would be what? +4, -1. So this would factor as x plus 4, x minus 1. Okay. So now that I have everything factored, anything that cancels out or gets simplified out, like these x minus 1s, are going to give us a whole. So on this one, we have a whole at that x value. That would give us a 0. So that means x, and when x equals 1, we have a whole, because 1 minus 1 is 0. Anything left in the denominator is going to give us a vertical asymptote. Okay, so in this problem, our vertical asymptote then is going to be at -4, because -4 plus 4 would give us 0. Okay, so since we already went over a bunch of these in class, I'm just going to have you guys try one of the two, B or C. Okay, figure out, so factor the numerator, factor the denominator, and then where's the whole, where's the vertical asymptote? Okay, if you did A, this is how it factored. You have difference of squares on the bottom, x plus 3, x minus 3. So that way when I simplify this, you should see that the x minus 3's would cancel. So that means you have a whole at +3. Okay, x plus 3 would still be left in the denominator, so you have a vertical asymptote at -3. If you did the second problem, C, there's your trinomial on top, factored as x plus 7, x minus 2. You had a difference of squares on the bottom, x plus 2, x minus 2. Those x minus 2's would simplify out, so that's where you have a whole. You have a whole at +2, vertical asymptote at -2. Okay, flip your note sheet to the back side. We're just going to finish up with how to find the x and the y intercepts. Okay, so here's your rules right here. Maybe I'll make a little star. Okay, to find the x-intercept, so the x-intercepts and the y-intercepts are where they cross your two axes, right? Your x and y axis. Okay, so the x-intercept you're going to find by setting your numerator equal to 0, okay, after crossing anything out. Okay, so you would set your numerator equal to 0 after it's all simplified. Okay, you find the y-intercept by plugging in 0 for all x's and simplifying. Now, an x-intercept would always be your number, comma 0. A y-intercept is always 0, comma the number, right? Okay, so let me go through A for you. I'm going to factor this out. We have a difference of squares on top. Square root of 9 is 3, so that will factor as x plus 3, x minus 3. In my denominator, I have a trinomial, factors of -15 that add to a +2 would be 5 and -3. So we'd have x plus 5, x minus 3. So we can see that these x minus 3's will simplify out. So what's left on top in our numerator is x plus 3. If I set that equal to 0, we should get that -3 is where our x-intercept is. Okay, to find the y-intercept, you would just then have to plug in 0 for every x that's left. So 0 plus 3 over 0 plus 5. Well, that's just going to give me 3/5, 3 over 5 left over. So that's where your y-intercept is. Okay, so follow the rules on top there. For the x-intercept, set the numerator equal to 0. For the y-intercept, you plug in 0s for all x's. So I'm going to have you guys try B and see what you get. Okay, here are the answers. Your x-intercept was at 1, comma 0. Our y-intercept is at 0, 1. So there's my work for that. So on the top, I set my numerator equal to 0. That's how I got 1 for the x-intercept. 0 minus 1 is -1. Okay, 0 squared minus 1 is another -1. So -1 divided by -1 gives me +1. Okay. All right, so in example 4, we're just going to put all of this together. So I have all the key features listed here. So I'm going to go through A, and I'm going to have you guys try B. So we're going to start by looking at the horizontal asymptote first, because you're going to get that before you factor anything. So let's look at our biggest x's. we have x squared over x squared. So remember, when our degrees, our exponents are the same, our horizontal asymptote is our ratio of coefficients. Well, my coefficients here are both little imaginary ones. 1 over 1 would give me a horizontal asymptote at 1. 1 divided by 1 is still 1. Okay, next up, let's do our vertical asymptotes in our wholes. So that means we have to factor this expression out. X squared minus 4 is the difference of squares. X plus 2, x minus 2. Okay. That trinomial, we're going to get factors of negative 10. That add to negative 3. That should be negative 5 and positive 2. So x minus 5, x plus 2. Okay, so I can see right away these x plus 2's are going to simplify out. That means we have a whole at negative 2. Okay, we'll have a discontinuity there. What's left over is x minus 5. So that means we have a vertical asymptote then at 5. Okay, our x-intercepts, let me rewrite this maybe as a simplified version. X minus 2 or x minus 5. To find the x-intercept, we take our numerator and we set it equal to 0. So that should solve out pretty quick. If x minus 2 is equal to 0, x would be at 2. So our x-intercept is at 2, 0. And lastly, to find our y-intercept, we substitute in 0 for every x that we have. So 0 minus 2 is negative 2. 0 minus 5 is negative 5. Negative divided by negative is actually going to give me positive 2/5. So there are a lot of key parts, but if you just kind of go in order of what we're doing, okay, like look the order of what they're asking you to find, it's not too bad. Okay, the vertical asymptotes and the wholes always go together. We always do the horizontal asymptote first before we factor anything, and then use those rules for the x and y intercepts. Okay, so I'm going to have you guys try this last one. Okay, I'm going to have you guys try B. You have x squared plus 2x over x squared minus x minus 6. So I'm going to have you guys start first by factoring. Actually, start by finding your horizontal asymptote. If you have x squared over x squared, where's your horizontal asymptote? Okay, if you did that right, x squared over x squared would be the same degree. Their ratio of the coefficients is 1 over 1. Okay. Now I would have you guys factor the top and factor the bottom, okay, and see what you get. If you factored it correctly, it should look like this. So now go ahead and find your wholes and your vertical asymptote. Okay, you should notice that the x plus 2's are going to cancel out. So that means you have a whole at negative 2. X minus 3 is left in the bottom. So that means you have an asymptote at positive 3. Okay. All right, let's do our x-intercepts and our y-intercepts. So in the x-intercept, set your numerator equal to 0. And what should you get? Okay, here's my work. So I got 2 x-intercepts at 0 and 2. And your y-intercept should be at 0, 0. And there's my work for that. Okay, you plug 0 in for every x. Okay, so we will practice finding all of these key parts, but it's just very important to remember kind of where all of them come from, okay, knowing all your rules. So head back to this note sheet anytime you get confused, like how to find the horizontal, vertical asymptotes or wholes, and the rules for the x and the y intercepts.